Light emitting diode or LED. We are familiar with this device LED. We found this component in most of the electronic devices we have, right? Let us see the working and the construction of this LED through this lecture. So this is the symbol of a particular LED, right? It seems to be like a symbol of diode, but here we see the two arrows here. So these arrows which are going outward from this diode represents light is emitted from this junction of this diode. So this is what the symbol of LED. So yeah, specified anode and cathode, right? So this smaller dash, that is cathode terminal, while this triangle side is what anode of this particular diode. So when it comes to the construction, right? So this is how a PN junction that look like for the LED. Okay, we have this P region here, and we have this N region here. Okay, and these all those regions are having the different kind of material, semiconductor material, according to the light that is we are going to use for particular application, right? Different atoms are vibrating, or they are having a certain energy, right? Different atoms, different elements, they have their own different energy, right? It's wise light is also having the different energy, right? A red one red light, it is going to have some smaller frequency. Then yellow light, it is going to have some higher frequency. And as compared to yellow, blue will have more higher frequency. Ultraviolet light, that will have again more higher frequency. So yeah, so the frequency increases as, right, as per this frequency increases, the energy is going to increase, right? That is completely dependent on the energy of those elements, right? Different elements with that particular different energy is going to emit different color spectrum, right? Different color of light. Yeah. So for that purpose, according to the light or emission we require, we are going to use that particular semiconductors to form this diode. Okay, P region and N regions. Okay, yeah. So what is happening? We have to connect, or we have to operate this device in forward bias condition. So what is this? Forward bias condition means what? We have to connect this P-type semiconductor to the positive power supply, while N-type semiconductor to the negative power supply. So what will happen? The carriers that are electrons and holes, which are the carriers within this semiconductor device, right? They will gain certain energy, and after gaining certain energy, they will, of course, they're going to excite to the higher energy state level. And as soon as recombination is going to happen at the junction, right? Whatever the energy, extra energy they have gained after applying the voltage, during the recombination of those carriers within this, yeah, PN junction, within the junction, right? During this recombination, that extra energy will be emitted by those carriers. Okay, that radiation, that is radiation, is what is in the frequency of visible light. Okay, that we can observe, right? Red, blue, yellow, green, all those, right? So this is how LEDs are going to emit light radiation. Okay, this is a very basic circuit diagram, right? So we have to connect a resistor that is going to limit the current through this diode, so that it will prevent the burning of or damage to this particular diode. Okay, remember we have to use it in a forward bias condition. Okay, so according to the different wavelengths, yeah, red, yellow, green, blue, right? So all those different semiconductor material, semiconductor LEDs, they will require different amount of voltage. So if we plot this forward voltage with respect to the forward current flowing through this particular diode, right? So what is going to happen? So for all those different light of LED, they are going to require certain different amount of voltage. Like for this red LED, we will say that it will require at least 1.8 volt to turn on or to flow the current through this device. And similarly for yellow, 2 to 2.3 volt. Right after that, this current is starting to flow, right? And then this green, right? Then this green, what we see, at least 2.3 or 2.7 volt is required to flow the current through this divide. And then blue, it will require 3 to 3 volt to flow through this device. Yeah, so this is how different energy levels of those different radiations will require different voltages for this all those LEDs. So yeah, here are the materials that can be used for the different type of light to be emitted, right? So in case of infrared, gallium, aluminum, and arsenide, this is the combination of semiconductor material which is going to emit 940 nanometer of wavelength. Then red, yeah, red, you can see gallium arsenic phosphate materials, semiconductor materials are used to emit 635 nanometer of wavelength. Then we see super blue or blue, it uses silicon carbide, gallium nitride. Okay, so nitrogen mixing is happening here. All right, semiconductor material is formed with this silicon carbide and gallium and nitride, okay, which will help to emit the wavelength of 470 nanometer. Okay, so this is what a particular LED constructed with different materials. Okay, yeah, application. So this is one of the application of 7-segment display, right? LED are arranged in such a way that we can form certain alphanumerical characteristics with the help of this arrangement. Okay, so yeah, how these are arranged? So these are the different diodes, right? One, two, three, four. These are named as A, B, C, D, E. So what we have done here, cathode of all those LEDs are connected to each other, and they are connected to ground shorted wave. So to on those LEDs, what we have to done is that a particular anode of the particular LED, we have to provide power supply. So that particular respective LED is going to turn and we will get that alphanumeric character display. Suppose we have to display A, so the LED E, F, A, B, C, and G, that we have to turn on. If suppose we have to display one, then LED number B and C will turn on. So this is how, yeah, we have to use these LEDs to uh, build different type of applications. Okay, so this was the common cathode where all the cathodes of all these LEDs are connected to ground, while another configuration is common anode. Okay, where anode of all those diodes are connected to each other. Okay, okay, yeah. So these are different applications we are aware of: signboards, traffic signals, various displays, indicators, right? Right. So these are the various kind of applications.